Prepare yourself for an extraordinary event. The massive red supergiant star Betelgeuse, positioned on the edge of our cosmic neighborhood, is sending out alarming signals that could potentially spell disaster for the universe. Astronomers, utilizing the James Webb Space Telescope, have uncovered startling new findings about this colossal celestial object. Renowned astrophysicist Brian Cox is raising urgent concerns, wondering if we may be on the brink of witnessing a cosmic explosion that could forever change the night sky. Betelgeuse, a star within the vast fabric of the universe, is known for its dramatic life cycle, where stars are born, evolve, and meet their end in spectacular ways. Recently, this enormous star has captured both public and scientific attention as it shows signs of a potential life-altering event. Betelgeuse is a truly massive star, about 20 times larger than our Sun. If it were to replace the Sun, its outer layers would extend beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars in its fiery embrace. This unimaginable scale underscores Betelgeuse's place in the stellar life cycle. Despite its massive size, Betelgeuse is at the end stages of its life, transitioning into a red supergiant. This phase is characterized by expansion and cooling as the star's core undergoes nuclear fusion, fusing hydrogen and helium to generate energy. Though Betelgeuse is young by human standards, it is ancient in terms of stellar lifespans, with an estimated age of 8 to 8.5 million years. In this relatively short period, the star has undergone radical changes, evolving from a hot blue star to the red supergiant we observe today. The temperature at its surface is much cooler than the Sun's, with Betelgeuse's surface temperature around 3,500 K compared to the Sun's 5,500 K. This cooler temperature is responsible for its distinct red color. What makes Betelgeuse even more fascinating is its fluctuating brightness. As a semi-regular variable star, its luminosity changes over time, with cycles lasting around 400 days and 5 years. Astronomers have long been intrigued by the star's erratic behavior. However, what truly sets Betelgeuse apart is its occasional deviation from its typical brightness pattern. This suggests complex and poorly understood processes occurring within the star's immense structure. In late 2019, Betelgeuse experienced an event known as the Great Dimming, where the star's brightness dramatically faded, drawing widespread attention. By February 2020, it had reached its dimmest point, becoming noticeably fainter to the naked eye, even in areas with light pollution. The timing of these observations is crucial. Due to the vast distances in space, the light we see from Betelgeuse today actually left the star about 725 years ago. This time delay makes it challenging to monitor and predict changes in the star's behavior. The sudden dimming of Betelgeuse raised questions about the challenges astronomers face in continuously observing cosmic phenomena, as well as the limits of our understanding when it comes to the immense timescales of the universe. Scientists at Harvard and the Smithsonian, led by Andrea Dupree, tracked the unfolding changes in Betelgeuse using the Hubble Space Telescope as part of a 3-year project. Their observations provided a unique look at the star's outer layers, which were heated by turbulent convection cells on the star's surface. These observations offered insight into the dynamic nature of Betelgeuse, a star whose variability is driven by cyclical expansions and contractions. By studying the star's atmosphere in detail, scientists were able to measure the flow of material in Betelgeuse's outer layers, providing a deeper understanding of the processes that may lead to the star's eventual transformation. As Betelgeuse's future remains uncertain, its recent behavior has only deepened the mystery surrounding this massive star. Whether we are witnessing the beginning of a catastrophic explosion or a temporary fluctuation in its life cycle, one thing is certain: Betelgeuse continues to fascinate and challenge our understanding of the cosmos. A massive material discharge was emitted by the star, a release that is estimated to be several times greater than the mass of the Moon. This significant event marks a major advancement in our understanding of both the star's nature and cosmic elements. However, what could this mass discharge mean for our theories on supernovae and cosmic explosions? The implications are considerable. Traditionally, it has been thought that red supergiants like Betelgeuse shed mass at a relatively steady rate before their inevitable demise in a supernova. But the size of this latest mass release challenges that theory, suggesting a more unpredictable and volatile life stage for these stars. Could Betelgeuse be preparing for its ultimate show, a supernova explosion, sooner than we expected? Recent studies suggest such an event might occur in just a few thousand years, possibly within the next few decades, rather than the previously estimated timeframe of 100,000 years. Another intriguing aspect of Betelgeuse is its bow shock, a phenomenon where the star moves through space at around 67,000 kilometers per hour, creating a shock wave, much like the bow wave of a boat cutting through water. This shock wave occurs as the star's outer layers interact with the surrounding interstellar gases and dust, providing valuable insights into the star's current state. Research into this bow shock is helping refine our understanding of mass loss processes and stellar evolution. Interestingly, Betelgeuse has been observed to cool and become less dense after the recent mass ejection, leaving the star in an unstable state, even years later. This ongoing instability raises questions about the internal processes driving these changes and how they might lead to its final demise. The mass loss rate of Betelgeuse is much higher than that of many other stars, indicating a complex interplay of internal forces. The recent exceptional mass ejection has sparked renewed debate about the star's future and what it means for its overall stability. Meanwhile, another noteworthy event, the discovery of the supernova SN 2023X, offers a fascinating point of comparison. The unfolding explosion of SN 2023X, an infant supernova, has captured the attention of astronomers worldwide. The star surrounding this explosion had a thick shell of gas, influencing the shockwave's escape. Two possible explanations have emerged for this dense circumstellar material. Either a strong, steady stellar wind had been shedding mass from the star prior to the explosion, or the star had experienced irregular eruptions, flinging material into space. By studying SN 2023X's explosion, scientists hope to gain deeper insights into the mechanisms that lead to a star's violent death. Given Betelgeuse's instability and the possibility of a supernova, it is widely believed that Betelgeuse will be the next star to undergo such an event in the Milky Way, although it may take as long as 100,000 years. Still, the potential for an impending supernova is a major area of focus in the scientific community, along with the opportunity for more research into stellar life cycles. Supernovae have long provided valuable information about stellar death, with notable events such as SN 1054, which formed the Crab Nebula, and SN 1987A, observed in the Large Magellanic Cloud. These cosmic explosions offer researchers critical data about stellar evolution and the processes that occur in the extreme conditions leading up to a star's end. The most immediate and visible impact of a Betelgeuse supernova would be the breathtaking light show in our sky, potentially outshining the moon and visible even during the day. This spectacular event would captivate astronomers and skywatchers alike. However, its true significance lies in the scientific opportunities it would present. Studying a Betelgeuse supernova would allow scientists to closely observe the final stages of stellar evolution. As massive stars like Betelgeuse explode, they release heavy elements including iron into space, elements crucial for the formation of planets, stars, and even life. By analyzing the spectroscopic signatures and distribution of these elements in the aftermath of the explosion, scientists can gain a deeper understanding of how stars evolve, generate elements, and contribute to the creation of new celestial bodies. Additionally, the supernova's release of neutrinos, elusive subatomic particles, would offer researchers a rare chance to study these particles in large quantities, potentially unlocking mysteries about the universe's most extreme environments. A Betelgeuse supernova could also provide insights into the universe's expansion and the enigmatic force known as dark energy. Given the vast distances involved, this may seem an unlikely opportunity, but it remains an exciting possibility. The focal point of the spectra indicated that material was leaving the surface of Betelgeuse and entering its outer atmosphere at a speed of nearly 200,000 miles per hour. Over time, this hot, dense material separated from the star, eventually forming a dust cloud that caused the star to dim over the course of 3 months after the ejection. Dupree and her team determined that roughly twice as much material was lost from Betelgeuse's southern hemisphere as was expected, given that all stars, including Betelgeuse, regularly lose mass, but at a significantly higher rate than our Sun. This mass loss raised questions among astronomers about whether the size of the ejected material and the resulting dimming might be a precursor to a supernova explosion. The mystery was further complicated by Betelgeuse's proximity to Earth, about 725 light-years away. Any such explosion would be visible from Earth and provide a rare opportunity to observe a supernova up close. However, the central question remains: is this dimming event a sign of an impending supernova, or is it simply a normal phase in the star's extensive and complex life? Several theories have been proposed to explain this sudden change. One common explanation suggests that the dimming represents a stage in the supernova process. Another theory proposes that the change was due to dust, possibly from the star itself, which could have formed a cloud thick enough to block light from Betelgeuse. A third hypothesis points to changes in the star's photosphere or surface layer, which could have affected its brightness. To address this puzzle, scientists conducted detailed investigations using various observational techniques. Spectroscopic data revealed that Betelgeuse's temperature decreased significantly, by at least 170 Kelvin, around the time of the dimming, suggesting significant surface changes. This confirmed the hypothesis that something on the star's surface caused the reduction in brightness. Eventually, the Hubble Space Telescope provided the crucial information that helped solve the mystery. According to Hubble's measurements, a massive eruption of hot material from the star likely caused the dimming. This material formed a dust cloud that obscured part of the star's surface, blocking some of its light. The eruption is believed to have been caused by extremely hot plasma from a large convection cell on the star's surface. This plasma passed through the star's heated atmosphere and reached its cooler outer layers, where it formed a cloud that covered about 25% of the star's surface. As Betelgeuse cooled, starting in January 2019, Hubble's ultraviolet spectroscopic observations played a key role in capturing the sequence of events leading up to the star's dimming. These observations showed evidence of hot, dense material moving through the star's atmosphere in the months before its brightness dropped. Ground-based telescopes also observed the star's dimming in December 2019, particularly in its southern hemisphere, as the material moved outward and cooled. Initially brighter than the star's typical brightness, this material eventually formed a shadow over the star. This sudden dimming event was thought to have been caused by the outflowing material and the resulting shadow it created. The scale of the eruption, with material ejected at a rate approximately 400 billion times greater than that of a typical solar coronal mass ejection, has brought Betelgeuse into the public spotlight on an unprecedented scale.